So as we all know that, and I'm briefing it from, I think, from our, since our first talk, that this initiative aims to provide a platform where the ECRs and scientists can share their work, exchange ideas, and foster collaboration across the different areas of value sciences and association sciences. So today we are delighted to host Dr. Barnita Banerjee, who is currently working as a scientist D at CSIR NGRI Hyderabad, India. She is also an INSA Women Associate, who reflects her significant contribution to the field of earth sciences. Dr. Banerjee completed her PhD in geology from um, GSR NGRI in 2018, following her master's in geology from Delhi University in 2013 and bachelor's in geology from the same university in 2011. Over the years, she has held several academic positions, including research associate at CSR NGRI and assistant professor at NIH Rourkela from between 2020 to 2021, before returning to CSR NGRI as a scientist C, where she served as a scientist C from 2021 to 2025, and currently she is continuing as a scientist D. So, if you talk about her specialization, her research focuses on paleo-monsoon variability, paleoceanographic variability, paleo-productivity, paleocyclone, which is super exciting for me today, and inorganic geochemistry using stable isotopes such as carbon, nitrogen, and oxygen to reconstruct the past environmental and climatic linkages in the Indian Ocean and surrounding regions. So, in terms of analytical expertise, she holds an extensive expertise working with advanced geochemical instrumentation, including EA-IRMS, Keel IRMS, ICP-MS, which are widely used in stable isotope and geochemical analysis. So today she is going to give a talk on the title The Southern Whispers in the Northern Sea, the paleo productivity and the climate linkage in the Bay of Bengal. And in this talk, she will be discussing the insight into the past ocean productivity and climate variability in the Bay of Bengal. So we are grateful to have Dr. Barnita Banerjee for accepting our invitation and sharing her research with the Paleo ECR India community. And I would like to mention that she was not well. She was going through some throat infection. Still, she agreed to deliver this talk today. So much for accepting our invitation and for being present here today. With this, I invite Dr. Banerjee to start the talk. So now I'll share her slides. Seconds.
I'm unable to.
Yes, ma'am. Just I'm sharing the slides. Give me this. Yes, ma'am. Over to you.
Yeah. Thank you, Alvin, for the generous introduction. Good afternoon, everyone. So, he has already introduced me. So, I am Barnita and I work as a scientist D in CSIR NGRI. So, since I have been a teacher, so now and then I can use one or two lines in Hindi because I'm used to that when I teach. So, please pardon me for that. And the topic is Southern Whispers in the Northern Sea, which is a little complicated. So by the end of this talk, I hope you will understand why did I write this Southern Whispers in the Northern Sea, because this entire talk will deal with the productivity in the Bay of Bengal, which is linked to the Southern Oceans. So let's move forward. So Arvind, can you just go to the first slide? So to begin with, since this community has also people who do not deal with direct oceanographic things, so I have kept a simple introduction that what is productivity. So basically it refers to the production of organic matter. So, and how is the organic matter produced? So basically the phytoplanktons, you can see in the picture on the right, they take up the inorganic carbon and they convert it into the organic carbon. And this organic carbon is further taken up by various heterotrophs, zooplanktons. So ultimately when they die, so the remains of the phytoplanktons, the zooplanktons, the fecal pellet of the zooplanktons, they form aggregate, you can see on the diagram below, and then they sink to the ocean floor, giving rise to the amount of signature of the past productivity. Okay, so and what does this productivity depend on? Obviously anything, any living organism will always depend on the food. And what is the food of these? What is the food? These are basically the nutrients. By nutrients, I mean they are phosphorus, they are your nitrogen, and then they are silicates. So all these are basic nutrients that they require. So it is always believed that the silicates mainly come from the riverine input, and the nitrates and the phosphate are mainly contributed by processes like upwelling and convective mixing, from where the cold water from below, which is nutrient enriched, they come up and they deliver these nutrients. So you see both the processes, that is the process from where the riverine input is coming and the process where the upwelling is taking place, both are dependent on monsoon. So basically productivity is dependent on nutrients and nutrients is dependent on monsoon. So productivity and monsoon, they are related. So as a matter of fact, when the monsoon, it's a general matter, when the monsoon is high, the productivity is high. When the monsoon is low, the productivity is low. So if we want to know the productivity today at this point of time, we have option of seeing the satellite images through satellite data. And we know, see in the picture below, there are two pictures on this picture on the global world map. You can see which ocean is more productive at present, what is the productivity and all these things. But if you want to see the productivity of the ocean 1,000 years back, millions of years back, what do? You cannot have satellite data or satellite images for that. So we take into account various proxies to study the past productivity, and that is what I do. And in this study, that is what I'm gonna tell you. So we move forward to the second slide. So glacial and interglacial control on Indian summer monsoon. So since I am in NGR, I often prepare slides generally because no one understands a lot of monsoon here. But since you all know, I will not go in detail that there are two monsoons, the southwest and the northeast. And the Indian summer monsoon is closely related to the glacial and the interglacial cycles. That is, the glacial period, they generally weaken the cross-equatorial pressure gradient and they reduce the monsoonal strength. And while the interglacial period, that is the odd MISs, are enhance the Indian low, and the monsoon rainfall is high. So when the monsoon rainfall is high, so that means the productivity will be high, and when the monsoon rainfall is low during the glacial period, the productivity will be low. So all this I'm telling you that the glacial period, the monsoon will be high, will be low, the interglacial it will be high, so the productivity will be high. These are general consensus. This will always not be true in every and each and every part of the ocean, but as a general belief, this is thought. So we move forward. So why did I choose Bay of Bengal? So you see, Bay of Bengal, there are n number of rivers that drain into the Bay of Bengal, and these rivers basically they carry with it a lot of terrestrial influxes that finally they deposit into the Bay of Bengal. So the Bay of Bengal is basically a house of so many sediments coming from so many parts of the Indian continent, the Himalayan region, the peninsular India. So it stores the information about the past monsoon. And it is influenced by both, that is the northern, that is the Himalayan runoff, and also the southern Indian Ocean processes. And now I would not say that the limited initially there was a lot of study when I joined my PhD, a lot of study was done in the Arabian Sea, whereas there was a limited amount of study being done in the Bay of Bengal. But now in the recent few years there has been studied, but yet the productivity study in the Bay of Bengal has been limited. And what does the productivity in Bay of Bengal depends on the climate linkage has also been meager in terms of other parts of the ocean. Paleo productivity. I think go back to the back to that slide. So basically that is the reason we took up a core in the Bay of Bengal, because our aim was to reconstruct the productivity, because we wanted to know it in the Bay of Bengal, because we believe it is a storehouse of information from so many riverine inputs and also various processes that goes around in the Bay of Bengal. So that is why we took up a core and assessed the productivity of Bay of Bengal since during the past 1.3 million years. We go ahead. So I will be often using the term because I have it's taken this study period known as your excuse me, mid-Pleistocene transition. So mid-Pleistocene transition was a transition which occurred between 1250 to 700 kilo years and is one of the most significant transition, because what happened during this period of time, initially before the mid-Pleistocene transition, the glacial cycles, where glacial interglacial cycle, were 41 kilo year cycle. And after that, the glacial interglacial cycle became very strong. The glacial cycle became very strong, and they became the time limit of the cycle became 100 kilo years. And why was it? There were various reasons because of that. For example, people believed that there were many hypotheses that was given. So one hypothesis was there was basal hypothesis. That means the regolith beneath these ice sheet with time got eroded. Now the ice sheet sat on the land part, so it became more stable. And as the ice sheet grew, so it reached upper, like at the altitude started growing at upper altitude, we have lower temperature, so it became more stable. And then there was a hypothesis that the albedo, as the ice sheet kept growing, the albedo got more stronger. So there was more positive, there was a positive feedback loop. So these ice sheet became stable. So once these ice sheet became stable, so what happens in these cases is, initially a small threshold was required to melt these ice sheets. So every 41 kilo years, because of the obliquity cycle, every 41 kilo years during maximum solar insolation, the ice sheet used to melt. But since they grew stronger, this linear threshold broke and that threshold increased. That is, you required more energy to melt these ice sheets. That is why the cycle increased to 100 kilo years. And then there are many number of hypotheses which said there was the CO2 drawdown and everything. So we'll not discuss it, but there was a major change in the configuration of the ice sheets. The ice sheet became more and more stronger. So since the dynamic of the ice sheet changed, and you know that Indian summer monsoon, it is very much pressure dependent. Okay, cross hemispheric pressure dependent. So since the dynamic of the ice sheet changed, so that will change the pressure gradient. And once the pressure gradient changes, what will change is its effect on ISM. So regarding this, what was the effect of MPT on ISM? There has been studies. So one school of thought believes that the ISM weakened after your MPT, and another school of thought believes that the ISM became stronger post MPT, based on micropaleontological assemblage and stable isotope geochemistry. So you see this graph, which is the lower graph, which is from the site U1446, which I will be telling you right now. It shows that, see the top one where benthic data is present, the cycle of the delta 18 benthic is slightly like low, like 41 kilo year cycle, and post that it becomes very strong post MPT, which is at 900 kilo years. It becomes very strong, which shows that the MPT affected this site as well. So we move forward. So the study area is U1446. So basically it is in the eastern coast of India, and it is offshore the Mahanadi basin, and the site is around 144 meter below the sea level in the western Bay of Bengal. So you know, because it is very near to the your riverine influxes, so it receives enormous riverine influx from Ganges, Brahmaputra and other Indian peninsular river, and also there is a fresh water is entrained in this EICC current you see in the picture. So, and overall this site, because it receives a lot of water from fresh water, so the salinity of this site is low because it has a lot of fresh water influx. So this is the site we worked on, and then we move forward. So we did, as I told you, and I'll also be dealing with this stratification and unstratified ocean. So basically what happens, as I said, this site is near to rivers, so often this site will become stratified. Now stratification will occur because of salinity, because of fresh water, like density difference, and density difference can be because of either your salinity difference or temperature difference. So in case the water becomes stratified, that is the less dense water is above and more dense water is below. So at that particular period of time, there will be no mixing. So this water cannot, the cold water cannot come up. So in that particular part, what will happen? There will be no nutrient exchange, and that is why the productivity will be low. If we talk of an unstratified ocean surface, and there due to cooling or winds, what will happen? The ocean stratification will be disturbed. There will be good mixing, there will be good nutrient influxes, and in that cases the productivity will be high. So I told you that to study the past productivity, we need a lot of proxies. So there are proxies which I applied. So we could move on to the next slide, please. So basically the proxies I used was a combination of biogenic and organic proxies. So I used CaCO3, I used total foraminifera number, I used sorry, biogenic barium, and I used phosphorus organic. And I also, for organic proxies, I used TOC content, delta 13C, delta nitrogen. I used few rock eval parameters like HI and OI, which I will be discussing, and also biomarkers. So see, I have used multiple proxies, and as a senior in this group, as a senior, I would always request all the youngsters to apply multi proxies. A single proxy can often lead to anomalous result. So you have to apply multiple proxies and see that if all these proxies point at a particular trend, that means you have a result. So we move on to the next slide. So you see, we applied for the productivity. So now we have to think that whether the productivity is a proxy of ISM at this particular site or not. So for this, we applied various proxies like CaCO3 MAR. MAR is basically mass accumulation rate. So whatever proxy we use, we multiply with linear sedimentation rate and the dry density. So basically we do it to remove the dilution effect from your terrestrial influxes. So we use CaCO3 MAR, TFN MAR, and barium biogenic MAR for phosphorus organic TOC. So we use 5 proxies for productivity, and we combined it with already published proxies from this site, which was SST by Clements, and summer monsoon assemblage by Bhadra et al, and then benthic and RB by CA. So this basically says you the runoff and runoff induced stratification proxies. So one common thing you see in these proxies, there is a line at 900 kiloyears. You see 900 kiloyears MPT line is there on the right hand side. Below that, all the proxies shows a very monotonous trend. There is, especially the productivity proxies, there is not much increase in the productivity proxies. The moment we cross the 900 kiloyears MPT line, the productivity shoots at certain period of time. You see the peaks over here in the CaCO3 at a particular period of time and again. So we thought maybe these were the period when the productivity started increasing. So basically these were the periods when the ISM was intensified. So when we established the chronology, we saw that these were the period, basically they were the glacial period. They were MIS 6, 8, 10, 12, 16 and 22. So probably we would have got it at 14, 18 and 20 also, but the resolution of our work was low, so we did not get all the or even MISs, but all the places where the proxies are showing a high are basically the colder periods, not the warmer period. So we see here that during the colder period, the productivity was shooting. So whether the ISM was high in the colder period or what was the reason, we didn't know until now. And you see here also what all changed. So we did an average. We saw that the CaCO3 and all the productivity proxies increased post MPT, isn't it? And this increase was basically because of the increase during the glacial period. And what else changed? The SST did not change a lot post MPT and pre MPT. What changed was the summer monsoon assemblage. The summer monsoon assemblage shooted post MPT, and the benthic delta 18O was also did not change a lot. The RB by CA did not change in the average, but the intensity of the stratification increased. So these are the changes we noticed, and then we moved forward to see that whether there was any change in the organic matter content. Since the productivity is changing, so we expect there will be change in the organic matter also. To check what kind of organic matter we had, we did the delta nitrogen versus delta 13C, and we saw that it was a mixed source. So generally in marine sediment, you obviously get a mixed source. That is, your sources are basically from marine and terrestrial. Then we did the GMM of S2 by TOC to see that how many sources were there. We again got 2 sources of organic matter. Then we plotted this HI. So HI is basically hydrogen index, and OI is your oxygen index. We get it through rock eval. So HI is hydrogen index and OI is oxygen index. So in terrestrial land plants, you get more cellulose. So the OI is more. And in your marine, you get more HI. So the HI is more. So if you see the plot of HI, you see that the marine organic matter is dominating at below 900, that is in the MPT. And post MPT, what is dominating? That marine is decreasing. We don't know what is dominating, but we can definitely know that the marine is decreasing. But all these are very qualitative analysis. We don't know we have yet not quantified. So for this, we did another very tedious analysis. Please go forward, Arvind. So right now we know that this is marine is contributing over here, but we have don't have a solid idea about what is happening to the terrestrial part. So for that, Arvind, can you please move forward? Yeah. So for that, what we did a biomarker analysis. And what we saw, we took samples during the MPT and we took sample post MPT as well. And one interesting thing what we got, that post MPT during the interglacial period and also during the glacial period, what we are getting is the higher alkanes. Now higher alkanes here means the land plants. So the terrestrial land plants are dominating in the terms of organic matter post MPT. And during the MPT, what is dominating is the lower alkanes, that is the marine. So we see now, until now, we have seen two changes, that the productivity is increasing post MPT, and post MPT, the marine is decreasing and the terrestrial domination is increasing both during glacial and interglacial. So these two changes were in our, is what we observed till now. With this, Arvind? So with this, when we observed these changes, so we kept on reading papers and we saw that we were not the only ones who got such changes. In this region, like around the Mahanadi basin, people have reported that productivity is very strong during during the glacial period, and they have given the hypothesis that this is due to northeast monsoon. So previous studies suggest that strong winter monsoon leads to boost in productivity due to thinning of low salinity cap, thereby facilitating effective nutrients from the photic zone. So basically they have said that during the northeast monsoon, what will happen, the salinity cap will break and then there will be upwelling and then there will be processes like convective mixing and everything. And that is why the stratification will break and that will lead to your enhanced productivity. So we thought that well and good, our data is matching with this and now it is easy for us to go forward with our paper. So, but when we were going forward, Arvind, please move forward. So what we saw that, the northeast, just click once more, the northeast monsoon comes from this direction, right? And Arvind, once more, please. And due to the Ekman spiral and Coriolis force, what will happen? The water will move in this direction. So that will never lead to any kind of upwelling or any kind of convective mixing. Rather, that will give rise to upwelling. Downwelling. Arvind, click once more, please. Isn't it? Because the water is moving from this direction. So due to the Coriolis force and Ekman spiral, it will move to the right hand side. And the right hand side we have a land mass. So that will give rise to downwelling. So how can northeast monsoon give rise to productivity during these period at this particular region where I was working? So with this, Arvind. So we thought that if at this side, if productivity is high during northeast monsoon because of processes like convective mixing and all these things, so at present also it should be high during the northeast monsoon. For this we collected last 20 years chlorophyll data and we saw that overall the productivity of this site is low. It is unlike the Arabian Sea or other site, is low, but still the productivity is high during the month of your summer monsoon month and low during the winter monsoon month. And then we went on to see few papers and it shows that this particular site during the winter monsoon is site of downwelling. And then we collected few more data. Arvind, can you just click once? We collected the density difference data and we saw that density difference and wind curl is negative here. So negative wind curl means downwelling. So indeed in the winter monsoon months we are getting downwelling and upwelling we are getting in the southern monsoon month. And also the surface density is also, see, if there is a lot of mixing, so because of process like convective mixing and all these things, so what will happen? The density difference will be low, right? But it is not the case. So the entire thing made us sure that northeast monsoon is not the culprit of increase in productivity in this particular reason. And then when we went into further literature, Arvind, go to the next slide. Next, please. We saw that this glacial monsoon, like various people have reported from elsewhere, For example, it has been reported in the Arabian Sea whether it was reported that a strong chemical weathering was reported during 14, 12, 8, 6. And then it was reported from this part of the Bay of Bengal around the 90s ridge also. And then it was reported like this Hecking Basin is influenced by both the East Asian summer monsoon also and Indian summer monsoon also. And it was a lake deposit over there where they pointed out that during the glacial period also they have received a high amount of monsoonal rainfall. So and productivity. So if northeast monsoon is the culprit, so it will not affect all this region in the same way. It might affect the Mahanadi basin as said in the previous papers, but not all these regions. So we thought it was not something local, like some kind of convective mixing going out around the Mahanadi basin because of northeast monsoon. If it is affecting the Arabian Sea, the Hecking basin, and other parts of Bay of Bengal, it has to do something with a global process. So then what we did, Arvind, please go to the next slide. 1 minute, just a minute. Okay, so these productivity proxies have a lot of noises. For example, CaCO3 have noise because of dilution, dissolution, and then TOC will have remineralization and all these things. So for that, we did one PC1 and productivity stack, so that these noises are removed, and we will know whether which portion the productivity actually increased. And then we combined it with various types of climatic parameters like the SST, the delta 18 global stack, and also the northern hemisphere ice volume and simulated southern hemisphere ice volume. So what we saw that nothing changed much at this particular site. Neither did the average delta 18 global or SST at that particular site. What majorly changed was, we know that the global ice volume. So we thought something, this productivity increase had to do something with the global ice volume. So we gave a theory that we move forward. Therefore, overall, it is written here. Therefore, overall increase in large scale change in interglacial glacial variability results. So what we saw that post this, what increased was the large scale glacial interglacial variability. That is, the glacial period became very intense. The ice volume at the Antarctic region became very intense. So then we thought of this hypothesis. We move forward. So what happens we all know that what happened post MPT was the glacial ice extent became very stronger and the ice became very stable. So A is basically the Antarctic ice sheets. So the extent became very larger and the ice sheet became very stronger. So the high pressure at the Mascarenhas region during the glacial period. So the A you see over here is basically the glacial period. There are two diagrams, A and B. So the A is basically the scenario of the glacial period. So you see the extent of ice sheet is more. So the high pressure is very strong. But the low pressure in the Indian region is not that intense because of, again, the northern hemispheric glaciation. But however, this intense high pressure, what it does is it compensates for the low pressure at Indian region, and then there is cross meridional circulation. So for a monsoon, you need a cross meridional circulation, you need moisture. So there is a cross meridional circulation, but that is not very strong. So the monsoon is there. So that is not northeast monsoon that is causing the changes. It is basically the southwest monsoon during the glacial period, also known as the glacial monsoon. So that is the glacial monsoon, but that monsoon is not that strong to create stratification. So we have nutrients coming from the riverine influxes, and then it is not creating stratification. So we have nutrients coming from convective mixing as well. So overall, we have a lot of nutrients, and that is why the productivity is very high. However, the productivity in the glacial period you are seeing is very low. So does that mean the monsoon was low? No. So what happens in the interglacial period, the extent of Antarctic ice sheet is low. So the high pressure is not that strong. What is strong is the low pressure in this Indian region. So there is a cross meridional circulation, and this gives to an intense monsoon. And because of the intense monsoon, there is stratification. So once there is stratification, what will happen? The nutrient exchange will become poor, and you will have a poor productivity. So in spite of intense monsoon, you are not getting the signature in productivity, isn't it? So does that mean that, so if you simply see the productivity signal and you think that productivity and monsoon are correlated, so we will interpret what the productivity is low, that means the monsoon was low. But was that the case? No. The monsoon was more intense during the interglacial period, but it is not coming in the productivity signature due to stratification. And the monsoon was also present during the glacial period, which was giving rise to the productivity. Was that northeast monsoon? No, it was the glacial summer monsoon that was giving rise to the productivity, because summer monsoon will give rise to upwelling. You remember, if the stratification is not strong. So we gave this hypothesis and we concluded our paper that it was the southern hemispheric forcing that led to the changes in productivity at this particular period of time, and it was not the northeast monsoon. So, Arvind, move forward. So, yes, then I discussed one thing that about the organic matter. So, this explains the organic matter also. So, since post MPT, we have during the interglacial period also we have intense riverine influxes. So, we have terrestrial organic matter dominating, and during the glacial period also there is summer monsoon and then riverine influxes. So, we have terrestrial matter dominating in both the glacial and the interglacial period post MPT. So, this explains the organic matter as well. So, Arvind, next slide, please. So, the conclusions we draw that all the productivity proxies we used show that the productivity increased post 900 kiloyears, which is the MPT when the ISM was intensified, resulting in higher riverine discharges. So, post MPT, higher productivity is reported at a lead from interglacial period. That is, the interglacial period showed low productivity, but the prior glacial period showed your high productivity, which is attributed to low Antarctic temperature. So the southern hemisphere forcing induced monsoonal event at glacial interval, leading to high nutrients availability from the riverine. That is what I explained, and also from mixing, causing increased productivity. The intensity of ISM caused stratification during the interglacial period. So in spite of having a very good monsoon during the interglacial period, we do not see the signature in productivity. So overall, what is the productivity in this site basically depending on? It is depending on the increased glacial strength post MPT. So this study also highlights that the use of productivity records as ISM proxies would yield largely different and incorrect interpretation. Because if we simply take the productivity proxy and interpret it in terms of ISM, you will get largely unwise results. We'll simply interpret that the ISM is low during the interglacial period. So at a site which is very near to riverine influxes, these productivity proxies should be used with caution. And also this study shows that future strengthening of ISM might lead to decrease in biological productivity in the northwest Bay of Bengal. So we always think the monsoon is high, so there will be high productivity, there will be high fisheries, but this is not true in terms of northwest Bay of Bengal, which is so near to the riverine fluxes. So this was our study. One more slide, please. So this is a very important thing which I would like to share with all of you, is that since this paper of mine was representing a very very new concept, and which was a not so accepted theory for explaining the productivity, this paper was rejected multiple times, and this is one of the quotation that straightforward what the reviewer suggested. So I'm quoting him, that using or her, I don't know, using the northeast monsoon route to explain the data is substantially more straightforward as it is simplest. Sensu chasm razor, which means that when two theories are explaining one thing, you take up the easier one. But we did not want to, because we believed in our theory. So we kept on, giving proofs of what we believed in. And ultimately, after 3 years, and after I think 12 rejections, this paper was accepted in P3. So as a senior to all of you and or most of you, I would like to say that it's a good reminder that alternative theories which you propose are not wrong or roadblocks. They make science more robust. So yes, science does test your patience, but if you believe in your data, if you believe in your theory, please don't give up to a reviewer. Go forward with it. Your paper will be accepted. So that's it. With this, I conclude. Thank you.
So, thank you so much, ma'am, for this wonderful talk. I think, in spite of having some glitch, we have successfully finished the talk, I think, very properly. So now I request the audience to please come up, and if you have any questions or suggestions or any comments or any discussion, please raise your hand, and then we'll come to you one by one, or you can just write in a chat box if you've got about your queries. anyone from the audience. So let me check the chat. Okay, well, let the audience think about the questions. Ma'am, I have one or two doubts.
Mhm.
Like we have tossed the term the glacial summer monsoon, right?
Mhm.
If I'm not
Yeah.
wrong. Yeah. So does it like just a terminology, or does it have some because there's a if it's glacial, there is a no there should not be any summer. So what about what is your view on using this terminology,
So
glacial
summer
summer
and
monsoon?
yeah, summer. So Arvind, the summer monsoon is also the southwest monsoon, right? Yes. So
Yeah, yeah,
basically,
yeah.
I'm calling it the summer monsoon because it is coming from the southwest direction. So I showed you that diagram because of the masculinous high pressure and the low pressure in the Indian subcontinent. So what is happening is the low pressure is not that intensified. You agree? Because not northern hemisphere effect is not that is there, and but the high pressure is very dominant. So this high pressure is compensating from the low pressure. The wind is coming from the southwest direction only. So southwest wind only can give rise to upwelling in this particular part because northwest will give rise to downwelling, which I showed. So it is the southwest monsoon, which is also known as the summer monsoon. So I use the term as glacial summer monsoon.
Okay. And uh, can you just tell me like what is the core depth of this the water depth of this core? Actually, I
14,
missed
1440, I think. 1440.
1440. Okay. So, if I'm not wrong, from the top, you basically mentioned about the nutrient from the riverine input, and also the deep water can also supply some kind of nutrient to the area,
Hmm.
and they can increase the productivity.
Hmm.
But during the colder time periods,
Sorry,
at
sorry.
most of the colder during most of the colder time periods, there is a huge dust flux coming from the surrounding continents, and it has been reported also.
What,
So,
what?
if you,
Arvind, can you just go back once from the cold period? What did you say?
yeah, so during the colder periods,
Hmm.
there's a huge dust supply reported in the Arabian Sea as well as in the Bay of Bengal, and also in the equatorial Indian Ocean.
Hmm.
And dust is one of the prime factors for increasing the productivity, even in the modern scenario, or the people have traced it in the past also. So,
Hmm.
uh, just only focusing on the nutrient from the river or
Hmm.
nutrient from the deep water, the dust can also be one of the strong, controller of supplying this, nutrient, and then it can also enhance the productivity in the particular field.
Yeah,
So, what is your
very,
view on that?
very, very good question, Arvind. So we also thought about it. Okay, and then this from this side the delta nitrogen, delta neodymium, neodymium isotope and strontium isotope has not been carried out. However, Pecketti et al. Has carried out just below this site, like U1445, and they have not reported anything like so dust sediments will have a different END and strontium. They have reported everything is coming from the Himalayan region, from the glacial period. It's basically coming from the HSCC, is a high Himalayan crystalline, and from in the interglacial period it is coming from the batholiths, like trans Himalayan batholiths. So nothing was reported. So with this we thought that if it is not reported at a site which is very near, so dust will not be a culprit here. So, but yes, when we are doing a productivity analysis, we should keep in mind the dust deposits as well.
Yeah, because why I'm saying this, even in the there are one or two papers from our group, and we
Hmm.
found a huge dust plus even younger dust, and even it's penetrating in the bottom of like 2,000 meter to the bottom of the sea.
Hmm.
But yeah, because uh, it is not
So, where
easy
is this
to,
dust coming from? What is the source of
yeah.
this dust?
So this dust is coming from the, African continents, North African, continents are the major supplier of this dust. Arabian Peninsula also they supply huge dust. But the trick is, uh, if your core is too much near to the some river mouth or some uh,
Hmm.
the location is where the sediment supply is high from the continent, it's not easy
Hmm.
to separate the signature of dust from the sediment coming from the rivers. So that's the one part.
Yes.
But
Hmm.
it doesn't. feel that there are many proxies by which we can directly talk about the Paleontology history. And I think, but yeah, as you're right, there are no such study reported yet. But I think we
Mhm.
can also think in this direction.
I
If
have
you are,
Sudhir has a question, I think.
yes, yes, yes. If you want, I can read. Okay.
Wait,
So
I can read.